the first one is we are taking B1, B2 up to B5M. Be the integers between 1 and m. That are relatively prime to m. So including 1. And we define the product capital B to be the product of these numbers. B1, B2 up to B5M. Right. The first question is to show that B is either congruent to 1 mod m or B is congruent to minus 1 mod m. So that you have to show. So how to show that? So yes, the question is clear.
Show that either B equivalent to 1 mod m. So the product would be equivalent to 1 mod m.
Right. Either 1 mod m or minus 1 mod m, any one of them. So the thing is, these numbers, BIs, B1 up to B2, B5M. So these numbers are relatively prime to M, right?
Right.
So that will give some idea. Right. So let us see how to do it. So the thing is, since the GCD of suppose BI we take, suppose for some I. So this is 1. So by the linear congruence theorem, what we have is BIX is congruent to 1 mod m. So this has a unique solution, right? Has exactly one solution, modulo m. So this is by that linear congruence theorem. Right?
Okay.
So by linear congruence theorem, we have that this linear congruence, that BIX congruent to 1 mod m, has exactly one solution in modulo m, right? So for each BI, that either there is some BJ, either there exists some BJ with BI BJ congruent to 1 mod m. So that is the solution here is X equals to BJ. Or BI square is congruent to 1 mod m. So either of this will happen. Right? So either I will find a different BJ such that the product of BI BJ is 1 mod m, or same BI will work. So that is BI squared is congruent to 1 mod m, right? Okay.
Okay.
So up to this is clear, right?
Let's see.
So there are two type of numbers here. So from the list that we have, the list of BIs that we have, B1, B2 up to B5, there are two categories of number. Either for a particular BI, I will find another BJ such that their product is 1, or I will the same BI if I square, that is 1. So it does not have another BJ. It does not have. Okay. So I can
Okay.
group the numbers. So here, since I have product of all the numbers, I will pair up these numbers, right? BI, BJ, I can pair up them such that it is one modem, right? So those number I can cancel from this product. That numbers does not. We don't need those numbers, right? Because their product as a pair, that is 1, right? So since we want to prove that it is either 1 or -1, so that pair of numbers whose product is 1, that will actually does not matter to us, right?
Okay, let's see. So, mm, okay, so you started saying that the GCD between all the b's and n is 1. Right, that is correct. And then you're saying any BI
Yes. So if
with
we
x.
consider this linear congruence, BIX congruent to 1 mod m, so this has exactly one solution. That is by the theorem.
So there is only one solution for that x.
Right.
And then for each BI, either exists some
X,
BJ with.
right. X is either some BJ from that same list, or it is BI itself. There only can be two cases, right?
So any two BI, any two B, you're saying the multiplication is either 1.
No, not any to be. I'm saying suppose I fix one BI, okay. So if I fix one BI, then I will get either some different BJ from this list, such that their product is 1, or if I multiply BI with itself, that is BI square, that is 1. So these are the only two cases possible.
Okay, you're deriving that from the
Yes, from
from
this,
saying that
hmm,
there is one solution for
right.
BIX. Right, so X is either BJ or BI, that's what you're saying.
Yes, yes. So X can be either the same BI, or X can be some different BJ from the same list.
Okay.
Right. Only these two cases are possible, right?
Mm-hmm.
Okay. So now the next observation, what I was saying is, so now if I look into this type of pairs where I have two distinct BI, one is BI and one is BJ, such that their product is 1, right?
Mm-hmm.
So these type of pairs will actually don't matter into this product of all the numbers, right? Because eventually this will only contribute to 1. So multiplication by 1 does not affect, right?
Mm-hmm.
So we can actually delete those pairs from this B, right? So if I want to give an example, so suppose B has 5 numbers, B1, B2, B3, B4 and B5, right? So B is the product of 5 numbers, and I want to find modulo M, what is happening to B. Suppose B2 and B5, they pair up together to become one mod M, right? So eventually I can, in the next line, what I can do is I can pair up B2 and B5, right? And in the next line I can just remove them, right? Because that is one mod M, right?
Mm-hmm.
So these type of pairs where they are together, and one modem, that we can cancel from that B, right?
Mm-hmm.
So up to this is fine, right?
Yeah.
Right. So any pairs bi comma bj such that bi bj, the product is one modem, we can cancel them from the product B. So up to this is fine, right?
Right.
Yes. So then we have to see what happens to this the second type of integers, or second class of integers, where bi square is equal to 1. We have to now take care only of those of them. Okay.
Mm-hmm.
So it will take some time. So do it. So maybe today we'll stop here. Tomorrow we'll do it.
Okay, thank you.